Hello everyone. So in this video, I want to cover chapter 4 for Packet Tracer 4.2.7. So this Packet Tracer to demonstrate Inter-VLAN routing using router on the stick methods. Okay, so what is Inter-VLAN routing? So remember that I talked about in previous Packet Tracer, a VLAN used to segment a network. A VLAN could be a small network within your overall infrastructure networks. So because you segment the VLANs, the networks in that VLANs, for example, a computer belongs to that VLAN, cannot communicate to another computer that's on a different VLAN. In order to fix that problem, you need to configure a process called inter-VLAN routing between the two VLANs or multiple VLANs. So that's where the term concept of inter-VLANs for this chapter it's about. So there are 3 methods that you can use to configure inter-VLAN routing. The first method, it's more of a legacy way to do this. It's called legacy inter-VLAN routing. So I would ask you to refer to chapter 4 to read about the 3 methods of inter-VLAN routing. So anyway, the legacy inter-VLAN routing, it does not scale well because it requires multiple physical interface on the routers for each VLANs. And a router generally does not have multiple physical interfaces like the switch. Okay, so this legacy inter-VLAN routing, it's not been used today as other methods. The method number 2 of inter-VLAN routing is router on the stick, which is going to be demonstrated in this Packet Tracer video. So this is a workaround to the legacy inter-VLAN routing because you don't need multiple physical interfaces for the VLAN's gateways. You can use one physical interfaces. Then you can create multiple logical sub-interfaces based on that physical interface. And you will see when we do the configurations in this Packet Tracer. The third method for inter-VLAN routings is based on a layer 3 switch. You've seen this before that we've done in the previous lab where you build a switch virtual interface, SVI. So SVI is an interface on the layer 3 switch that represent the gateways of the VLANs. I don't know if you remember, we built an SVI for the management VLAN 99 in previous Packet Tracer. That is an SVI on a layer 3 switch representing the gateways for VLAN 99. All right, so please refer to chapter 4 for inter-VLAN routings reading. So with that said, let's get into this Packet Tracer labs. So the objectives, we got 3 parts. Part 1, to add VLAN to a switch. Part 2, configure sub-interfaces. Part 3 is to test connectivity between PC1 and PC3. So let's start with part 1, adding VLAN to a switch. So we go to switch number 1. So we want to add VLAN 10 and VLAN 30. So let's start by adding VLAN 10. Now you can name it data 1 for VLAN 10, and then VLAN 30, name it data 2. So that's step 1. Step 2 is to assign the VLANs to the ports on the switch that connect to the PCs. So if we look at the topology here, so on switch 1, fast Ethernet 0/11, it's going to be assigned a VLAN 10. So we want to go to interface FA011 and assign a switch port access VLAN 10. So that interface connects to PC1. Then we want to go to interface FA06, and we want to assign the switch port access VLAN 30. Okay, and this interface is connect to PC3. Remember, do a no shut. Alright, so that is step 2, part 1 completed. So let's verify what we've done. Have we assigned VLANs to the correct interface? So here's the show command. Remember, show command is an operations of privilege user mode, right? Privilege mode. So show VLAN brief. So we can see that we created 2 VLAN, VLAN 10, VLAN 30, and we assigned the interface that connect to the PC to the right VLAN, right? So that's noted here, highlighted here. All right. So step 3, we want to test PC1 to PC3. We want to use ping. Remember, ping is a tool that you use to test connectivity, simple connectivity between network devices or computers. So if I go to PC1 and I go to command prompt, and I know PC3 has an IP of, let's take a look. So it looked like a typo here. It's a PC2, but essentially it is PC3. So we want to ping this IP address to see if we get a response from PC1. So I'm going to ping 172.17.30.10. So my guess is here it's not going to work because you have 2 computers. They are assigned to 2 different VLANs. And by the concept, this will not work until you have inter-VLAN configurations, right? Whichever method that's going to be used in this packet tracer, we're going to have to build a router on the stick methods, right? That depends on the routers. So we have not done that yet. So the communication between PC1 and PC2 will not work. Alright, so let's move to part 2, configure sub-interfaces. So this is the configuration on the router 1 here. So again, refer to chapter 4, read on what router on the stick means, what are the use cases. So let's start router configuration. To build a router on the stick configurations on the router, first you want to make sure the physical interface that connects to the switch needs to be turned on. So that is interface gig 0/0. Misspell my interface gig 00. Do a no shut, and that should be all you need on the physical interface. But you need to build the sub interfaces. So sub interfaces on the routers represent a logical concept to represent a gateway of a VLAN. Okay, a VLAN is gonna depend this gateway to communicate to another VLAN. So let's build a sub interface based on this packet tracer. We need to go to build a sub interface called .10 out of that physical interface gig 0/0. So interface gig 0/0.10, and we want to do the encapsulation .1Q10. So this is the encapsulations for that trunk protocol. The 10 here is a representation of a VLAN ID 10. Okay, so this sub interface gig 0/0.10 is a representations of the gateway for VLAN 10. So you want to add the IP address for VLAN 10 gateway, right? And make sure a no shut. So you want to do the same for sub interface .30. So the sub interface is still going to base on that one physical interface on the router gig 0/0. So you want to do gig 0/0.30 with the encaptions protocol .1Q protocol for VLAN 30.30 and an IP address to represent VLAN 30 gateway and a no shut. Right. So now what I just did was the configurations of the router on the stick for the router on the router side, right? Show IP interface brief. So this command will let you look at the configurations of the IP addresses that you configure on the interfaces. Okay, so we built a sub interface gig 0/0.10 and we assign the IP address. We built gig 0/0.30 and we assign an IP address. These IP addresses, again, it's a representation of the default gateway for the VLANs 10 for this guy, VLAN 30 for this guy. Okay. Right, at this point, again, the lab asks us to do another connectivity test between the two PC. And my guess is here that it's still gonna fail The reason is that we need to do something on the switch as well for the router on the stick configurations. We've done the routers, but we also need to do a configurations on the switch as well. So as you can see, the communication, the ping is failed. Right. So on the switch, because so let's do a show. So we on step 2, show VLAN. So we look at the switch gig 0/1. So gig 0/1, it belongs to a default VLANs. So right now, because it's connected to a routers that has configured two sub interfaces for VLAN 10 and 30, but the interface on the switch does not belong to those two VLANs. That's where the problems of the connectivity between PC1 and PC3 at this point. So the interface on the switch that connects to the routers, that needs to be in a trunk mode. If we remember, a trunk mode, trunk interface allows multiple VLANs going across that interface. We need the switch to be able to pass VLAN 10 and VLAN 30 on that trunk interface that connect to the router. So we need to enable gig 0/1 on the switch as a trunk mode. Okay. So interface gig 01 switch port mode trunk and no shut down. Okay. At this point, we wait until everything is green on the interface and we'll test one more time. Alright, so interfaces are green. So let's do some show command here to see what we've done is correct. So let's issue the show interface trunk command on the switch. Now you can see gig 0/1, it's in the trunken state. Okay. So at this point, let's see if we can test from PC1 to PC3. And here we go. So successful at this point. Okay, so at this point it is complete, but you see my completion here is 83. So if you can do a check results to see what you missed. For me, because I named the VLANs different than the switch, than the actual packet tracer wants, so it's marked as not complete. But again, don't worry, you don't have to complete 100% as long as you get the concept and the idea of what the labs it wants you to learn. Okay, so at this point we have completed this packet tracer, and I will see you guys on the next packet tracer.